Hello everyone. Today we are going to look at yet another case study. This time we are going to look at selective laser sintering approach. The product that we are going to look at is a case study on compound bow which are being used in archery. Okay, so in archery the schematic diagram has been put here. Okay, the actual diagram. And then here you see a cam here, this part and this part. Now this as light as possible, as strong as possible is the requirement to make a bow. Okay. Now let us see further. This is an adaptation of a paper designing for metal additive manufacturing, a case study in professional sports equipment field. Okay, it has been presented in the year 2017. It's an Italy paper, and the author have very clearly said that in the paper that they discuss the possibilities of availability as well as the challenges that have been faced during the design of metal additive manufacturing, especially during the selective laser sintering. What they are trying to concentrate here is that how the design for additive manufacturing plays a role and how they were able to improve the quality of the design using additive manufacturing, and what were the challenges that have been faced by this. Okay. Here, as I said this in the introduction, let us introduce ourselves to the case study. The case study reports the possibility and the possibilities available as well as the challenges faced during the designing of metal additive manufacturing. It focuses on the redesign activity performed on the cam system of a compound bow. There is a cam system where it tries to tighten the cable or loosen the cable based on its rotation. Okay, so there must be a groove where the cable must be moving, and it must be hinged about a fulcrum point. The functional analysis, manufacturing and the assembly constraint, along with the various strategies applied for printing of the object, is being discussed here. Now, what is selective laser sintering? Okay, it is one of the additive manufacturing technology or strategy that has been available to us, and here we use a powder. Okay, it is an additive manufacturing technique. Then it uses a laser as a power source to sinter. Sinter is trying to melt and join the powder together of typically a nylon or a polyamide, aiming the laser automatically at points in space defined by 3D model, binding the material together to create a solid structure. Now here we are talking about nylon and polyamide, but actually there is a metal sintering also available, and in this particular case study we are using metal sintering. The process is same. Okay, so let us look at the process. The process goes like this. You have the powder, metal powder, that one, and it gets smeared onto the platform, and once it gets smeared, then the laser comes, and then on the 2D geometry of the part which has been sliced will get laser treated, and then they get cured. That will be the sintered part. This table then moves down. This table then moves down. Okay, then the excess powder comes to this place. Okay, or sometimes it may be two-way also. One way moving on this side and the other way. So the roller constantly spreads the powder onto the build platform, and then the laser cures it, and as the table goes down, the part gets built up here. Okay, and finally it is even taken out. It can be taken out. Here there is no support that is required because it is all layer by layer. It is getting treated, and we can always try and do some kind of a post processing on the final part. Now, the schematic cam system assembled to a compound bow is shown here. This is how the cable moves around. Okay, a crisscross way. There you see the complication of this part. Now this entire thing has to be handled by a male or a female sports person, and so it must be more a lightweight, but it must be strong, heavy to launch the bow. Okay. So this is what is the schematic diagram and the entire diagram that has been shown here. So additive manufacturing plays a role in trying to manufacture of this particular product. Now, the main features and the elements of the system with its exploded view highlighting the housing and the anchoring elements for strings and the cables are shown here. Now, what you will have to look at what is the volume of the entire part, how much is the size, how much space does it occupy, the encumbrance space, its moving space, etc. When it rotates, how much of space that it occupies, the square space that it occupies is also been to be studied. Now, further a detailed geometry of the tracks and the pin of the detail of the pin housing. You see there is a pin housing here. Okay. Now, whether it is a decision to be taken whether the pin housing has to be made or at the time of additive manufacturing, or do we because it is a point of geometry where it has to be controlled. So, do we try and do it as a secondary operation? That is a decision to be taken. Now, you see the complications or the precision that is required for the tracks and the geometry that is there for the semicircular geometry that is there. Okay. Now, this is where the cable is going to go around the pulleys there. Okay. Now, they have tried a different kind of orientation for this. Whether it could be mass manufactured, where they are going to make 6 modules of this, what will be the height of the part, how much of surface support that has to be required, and what is the volume of the area of the surface support, or the volume that has to be done for the surface the support operation. Optimization is being carried out on this, and the ASIS system. Okay, currently this is how the part is, and then they try to optimize it, considering the target of minimization of the XY projection. They want to this slide they want to try and minimize the XY projection now. Now, the next one is they want to minimize the support surface. Now, here they have taken 4 modules there, and then they try to make a 45 degrees orientation of the part. Now, once they try to do with a 45 degree orientation, what will be the Z height and the support surfaces, okay, that are also being calculated here. Again, next iteration, they try to minimize the Z height. The total height, the optimization on the Z height of the object with respect to the printing platform is also being done, and they try to arrive at the proper Z height also. So, in all the 3 iterations, they try to check the support surface, the area that has to be the volume of support that it has to take, and the total height, the Z height, and the XY printing area also they try to study. Now, with all these things, they have tried to redesign the part now. Okay, in trying to redesign, they had tried to make some places as open for easy insertion and removal of the cable. Now, that is also an important thing, that the cable has to be inserted and then removed, etc. So, for that they try to remodify the part. The geometry itself got changed. Okay, the volume is come down, and the pinhole is to be pinhole. This one they have left it for machining purpose. They are making it as a solid, and then they are leaving it for the machining purpose now. Okay. Here we see a lot of holes are also being printed here. Okay, for lightweighting. Then the horizontal section view of the cam is shown here. Okay, they have cut here, and then there is a 45 degree rule is there. The holes are made in a rotated manner, such that the 45 degrees to the angle of printing. So, when it is 45 degrees, the support need not be there. It can be self supported. So, the support structures can be brought down. So, open zone for easy insertion of the removal of the cable. Rigid connections among the 3 cam parts have been done. Pinhole to be obtained through the machining purpose. Okay. And and the horizontal cam view is also there. Okay. Now, an overview in red shows that all these things are the supports that are there, and the printed cam is shown here. And after removing the cam and then short plastic, they have done this part now. Okay. In conclusion, they have definitely claimed good results there, that 20% of the volume reduction has taken place. A new design is there. Design for additive manufacturing itself is a different area that which helps us to look at the design itself in a different manner based on our additive manufacturing. But they have also highlighted some of the drawbacks. They say that, here they say the discussion has further highlighted what has been already underlined in the literature, that is the lack of integrated design tools in order to reduce the design iterations given by the necessity to frequently check the printability of the solution when the complex changes and the geometry are there. So when now this is a new era of additive manufacturing. So I have to keep on checking whether it can be printed or not. So for that, the simulation is required. Whether to whether the printability when I make some changes during my design, whether it can be printed, that is lacking. The second, there is also a lack of tools of consolidation of procedures to support the decisions about the selection of optimal trade-off among the various functional, technical and manufacturing requirements to be taken into account while design for additive manufacturing. Now, this has been successfully done. They have definitely pointed out that the lack of some kind of facilities or tools that is required for the additive manufacturing purpose. Okay. So in this particular case study, we have looked at how selective laser sintering is being used in metal additive manufacturing purpose. We have studied the case study is on more on a sports item, the bow, used for archery, the cam part of the bow of the archery there. Now we will meet during another session, and thank you very much for joining.